Okay, chapter 4, pressure in fluids and atmospheric pressure. So two topics, pressure in fluids and atmospheric pressure. Now, how are they different? Think your atmosphere is also a fluid, right? Fluids is any liquid or gas. So when we say pressure in fluids, we're talking about being inside the fluid. Okay, and atmospheric pressure is also similar because you're inside the atmosphere and the pressure of the atmosphere is being exerted on you. Okay, so pressure in fluids and atmospheric pressure is very similar. Okay, so first we have the topic of thrust and pressure. Thrust is also called as force. Okay, and these two topics were already taught in 8th standard. The formula for force, or the definition for force, and the definition of pressure. So can you tell me what is force? Thrust or force? They are the same thing. What is it? Do you know a definition for it? We can say force is a push or a pull. Okay, force.
Pressure felt, right?
Was it Nishta?
It's the pressure felt by an object on Earth.
That is
No?
pressure. Force,
Okay.
force and pressure are very similar, but there's a difference. Okay, so I'll show you the difference. Force is like thrust or weight. When you stand on the earth, your weight, or you feel a sense of weight because of your mass, which is exerting a force towards the earth. It's due to gravity. Okay, gravity is allowing your mass to exert a force towards the earth. If there was no gravity, then you're not exerting any force towards the earth. You'll be floating. Okay, so it is gravity that allows you to exert a force onto the earth. If you leave a pen on the table, okay, the pen is exerting a force downwards. This force is exerted due to gravity. Okay, so this force is exerted just due to gravity. So thrust, force, and weight, they all are the same thing, or they can be interchangeably used. They have the same unit. The unit for force is Newton. Okay. Now, what is pressure? Pressure is force upon area. So it is a force exerted, but on a certain area. Now, there's a very nice example. If you take your pen like this, okay, one end of your pen is sharp, it's pointed. The other end of your pen is flat. So suppose you take both hands like this and you press like this, there's equal pressure applied on both the hands. You're applying equal pressure on both the hands. But what happens on the pointed area? It pains more over there. Why is that? It's because there's more pressure. Why is there more pressure on this point here? It's because its
Because
area
it's
is less. Yeah, the area of contact to your hand is less. Okay, so
concentrated.
it's concentrated
The
on one point, right? So what this tells you is the lesser the area of contact, more the pressure. Okay, see this formula over here. You see force is in the numerator. So force is directly proportional to pressure. More the force exerted, more the pressure. Area is in the denominator. So area is inversely proportional to pressure, which means more the surface area, lesser the pressure. Or lesser the surface area, more the pressure. Okay. Do you understand this concept, everyone? When you take your hand and press on the pen, the force exerted on both the ends of the pen are equal. Okay, the same force is felt, but the pressure on the pointed area is more because area of contact is less. Okay, so let's take a few examples. First, let's compare force and pressure. Okay, if there is a horse and a let me give an example of a car and a truck. Okay, there's a car, there's a truck. Now both of them have the same tires. They're using the same tires. Okay, which of these two have more? Which of them has more force? Which of them is exerting more force onto the ground? Is it the car or the truck? See, force is weight. Okay, so which of these two has more weight? It's the truck, right? So since the truck has more weight, the truck is exerting more force onto the ground. Okay. So if a truck is having the same tire, the width of a tire, same width as a car, the truck might Suppose the car and the truck both are driving on mud. Because of the weight of the truck, because of the force of the truck, it will exert more pressure and the wheel might go into the mud. Okay, why? Because the truck has more weight. So to prevent the truck from getting stuck in the sand or going in the mud, what do they do to the truck? They don't give same tires like a car. They give much more broader tires. The tires are more broader. You understand why it is broad? More area of contact with the soil.
Less pressure exerted on the road.
Yes, by increasing the area of contact, you're able to reduce the pressure on the road. Okay. So if you notice, any vehicle that is heavier and bigger will always have fatter tires to reduce the pressure exerted on the road. Okay. Now, if you want to increase pressure, what should we do is we reduce the area of contact. For example, a knife. You're cutting vegetables. The knife is supposed to be sharp, right? Because the sharper the knife, the lesser the area of contact, there is more pressure. Okay. Or a nail, if you're hammering a nail into the wall, the nail should be sharp because the sharper the nail, lesser the area of contact, more the pressure. It will easily go into the wall. Okay. So like this, the pressure can be increased or decreased just by changing the area of contact. Okay. All right. Now, what are the units for pressure, force, and area? For force, we saw the unit for force, that is Newton. For area, what is the unit?
Meter per square.
Meter square. Just meter square. And so according to this, the unit for pressure would be Newton per meter square. You'll write it as Newton meter raised to -2. It's read as Newton per meter square. This unit, was that Nishta?
Nothing,
Yeah.
sir.
So this same unit can also be written as Pascal. The unit Newton per meter square can be replaced by the unit Pascal, which is the standard unit. It has been named after a scientist named Pascal. Okay. So Pascal is the standard unit for pressure, which is same as Newton per meter square. Okay, write down this formula for pressure with the units. Yeah, it's named after the French scientist Blaise Pascal. Keep your notebooks open, just write down these small points, then we'll move on. Okay, we'll move on. What is the definition of 1 Pascal? So for that, we just write. Yes, Hiba.
So can you just tell me, like, force is directly proportional or not directly or indirectly?
Force is directly proportional to pressure. See, force is in the numerator. Anything in the numerator of a formula will be directly proportional to this LHS. And whatever is in the denominator will be inversely proportional to pressure.
So then force will also, pressure will be also directly proportional to force.
Yes, you can say it either way. Either force is directly proportional to pressure or pressure is directly proportional to force.
Okay, sir. Thank you.
Yeah. Okay, so what is 1 Pascal? So 1 Pascal is equal to 1 Newton per meter square. Right? This is the units. We can use this relationship to define what is 1 Pascal. Okay, so if you look at the definition of 1 Pascal written in your book, 1 Pascal is a pressure exerted on a surface area of 1 meter square by a force of 1 Newton acting normally on it. Okay, so what is 1 Pascal? It is a pressure exerted when a force of 1 Newton is exerted on an area of 1 meter square. Does that make sense, all of you? Like imagine you have a weight of 1 Newton and it is sitting on a surface of 1 meter square. So that pressure exerted by that object is 1 Pascal.
So what does acting normally on it mean?
Normally means perpendicular, and perpendicular means 90 degrees, right?
90 degrees.
So if this is the surface, you have to see the force acting perpendicular to the surface, not diagonally or anything. Okay, that is the meaning of normally. Okay, is everyone clear with the definition of 1 Pascal? And now there are other units other than Pascal for pressure. The other units of pressure. Standard unit is Pascal. And we know that 1 Pascal is equal to 1 Newton per meter square. Now you have the CGS unit for pressure. In the CGS unit, you convert both the units, Newton and meter, to this smaller unit. So Newton will become dyne, right? You all know the relationship between Newton and dyne. 1 Newton is 10 raised to 5 dyne. This is the conversion between Newton and dyne, right? So we're converting Newton into dyne and meter into centimeter. Okay, so Newton per meter square, when you convert that to CGS unit, that would become dyne per centimeter square. Now, the relationship between this, you can just memorize the relationship because it's a derivation that is not required. So you can just remember that 1 dyne per centimeter square is equal to 0.1 Newton per meter square. Or if you multiply both sides with 10, we get what? 1 dyne per centimeter square is equal to 1 Newton per meter square. This relationship you just have to remember. You might not require it anywhere because we need to solve everything in the SI unit. Okay. And before we use the formula of pressure, we're already converting everything into the SI unit and then applying. Okay. So very unlikely you will get the unit of pressure in the CGS unit. But in case you do, this is the conversion between the CGS and the SI unit of pressure.
We will so multiply it by 10.
Yeah, from Newton per meter square, that is Pascal, to dyne per centimeter square, you will multiply this with 10.
Okay, sir.
Write down this. Okay, you can also have another unit, like we know the formula for pressure, which is force upon area. So if force is taken sometimes in kgf, then area will be in meter square. So the pressure, the unit of pressure would be what? kgf per meter square. Okay, this is another unit. Again, not standard unit, but that's a unit. Then you can also have this SI, the CGS unit, the smaller unit, which is gram force. For force, we can take gram force, and for area, we can take centimeter square. So that way the unit would be gram force per centimeter square. There's a minus here, okay? Gram force per centimeter square. Okay, just note down these different units. You just need to know them in case you'll have to use them. There are a few more units like atmosphere. So atmosphere was based on the atmospheric pressure at sea level. Okay, see, above us, there's 300 kilometers of air, right? So we are at the bottom of this big blanket of air. So we are at a point where there's a maximum amount of atmospheric pressure. As you climb up, go higher up, climb a mountain, what happens to the atmospheric pressure? It decreases, right? Because the quantity of air above you, not quantity, the distance of air above you gets lesser as you climb up. So the maximum atmospheric pressure is at the sea level. Okay. Right now we are at Pune. What is the elevation of Pune? Do you know? How high above sea level are we? Do you know approximately how many meters above sea level are we? Come on, give some guesses. Don't be quiet. What is the elevation of Pune? Are we at sea level? Have you gone to Mumbai? Mumbai is at the sea level, right? So there the elevation is like 0 meters or 2 meters or 5 meters. That's the elevation. Pune is around 600 meters above sea level. Okay, so the atmospheric pressure in Pune is much lesser than the atmospheric pressure in Mumbai. Now, as you go higher, like you climb a mountain, like Mount Everest, that's the highest point. Mount Everest height is 8,800 meters around, right? So there the atmospheric pressure is very, very less. You have to take an oxygen mask if you're climbing the mountain there because there's less atmospheric pressure or less air at the top of Mount Everest. Okay, so at the sea level, 1 atmosphere is the pressure. And that's 1 unit. Another unit is mm of mercury. So we can take the atmospheric pressure at the sea level is 760 mm of mercury or 76 centimeter of mercury. Okay, so all of these are different units for pressure. Okay, how many units have we seen till now? We saw Pascal, so Newton per meter square. We saw dyne per centimeter square, kgf per meter square, gf per centimeter square, atmosphere, mm of mercury. Okay, and this mm of mercury can also be taken as something called TORR, torr. They are the same. Okay, so 1 torr is equal to 1 mm of mercury. Okay, all right. So these are all the different units for pressure. Note down these. Note these down. Okay. Next. Now in my hand here, I have a remote. It's in the shape of a cuboid. It has a certain amount of weight, which means it has that amount of force. When it is placed on an object, it's exerting a certain amount of force. Now, in whichever direction I place it, it will exert the same amount of force on my hand. Okay. But will it exert the same pressure in all the different directions if I place it? Will it exert the same pressure or will the pressure be different? The pressure will be different, right? So in which position do I have to place it to have the maximum pressure on my hand? Like this or lying flat? It has to be like this, right? Because in this particular position, there's the least amount of surface area which is touching my hand. Okay. So here there's a diagram over here of something that looks like that remote, and they have placed it in 2 different positions. So on the left side, it is placed in the position where there's the least amount of surface area, least contact. Okay, the surface area is the least in this first position. And the second one, it's lying on the flat edge. So that's the most amount of surface area. So finding area, the area in the left side is 10 into 5. 10 into 5, right? Because that is the sides that is touching down. So 10 into 5, 50 centimeters square is the surface area touching the bottom. On the second image, look at the area. How much is the area over here? Yeah, like breadth is 20, length is 10. So 10 into 20, that is 20 centimeters square. Okay, so because there's a much greater surface area, there's a lesser pressure on the right side. Okay, is that clear, everyone? Okay, so then you have a lot of examples stating that if you reduce the area, you'll increase the pressure. Okay, like we have already seen of that. Ways of increasing pressure. How do you increase pressure of a nail or a knife? You just make it sharp. How do you decrease pressure? By increasing the surface area. The heaviest vehicle is a train. Okay, and the train has the most amount of force exerted on the earth. So to reduce the pressure, what do? Put these rails, and under the rails, you've seen these things are called sleepers. They used to be made of wood before. Now they're made of cement. Okay, and they increase the area by a lot. And that is placed on top of rocks or big stones. So that way the surface area is increased so that when the train goes on that, it will not sink into the mud. Okay. Also, you can see foundation of buildings are made wide. And as the building grows taller, sometimes it gets narrower on top. Okay, I'll read this. The foundation walls of buildings are made wider than the remaining walls. Okay, about the walls also. So walls are, say, 1 feet thick, but the foundation is much wider. Okay, so that is to reduce the pressure. The taller the building, the wider the foundation has to be, because the taller building is more heavier, and more heavier means more force exerted. So to reduce the pressure, they have to widen the foundation. Okay, so that is all about this particular formula. P is equal to F upon A. So that formula is used whenever an object is exerting force on a surface. Okay. Now the second topic is pressure in fluids. See, now we're starting pressure in fluids. So pressure in fluids means if you're inside a fluid, what do you mean by fluid? Fluid is a liquid or a gas. So if you're inside a fluid, then the fluid above you is exerting a pressure on you. Okay. So now there are a few important
So,
points.
so if you're swimming,
Yes.
the air is exerting a pressure on you.
If you're swimming, then the water is also exerting pressure on you. Right?
Yeah, but like let's say if you're in a pool but you're just still,
Hmm.
then it's the air, right?
Are you under the water or you're above the water?
Above.
If you're above the water, then we don't have to talk about the water because we're talking about the air above you, right? So whether you're standing in land or swimming on the surface of water, the air pressure is what's on top of you. So the water is not
And
considered.
so if,
Okay. Huh?
and so if you're underwater,
If you're underwater, then we don't consider the air because you're under the water. So the water is exerting pressure on you. Okay.
oh yeah.
Yeah. So now let's talk about water because water is a very understandable fluid that we can relate to. Okay. And all of you have swam, I'm sure. Have you all swam under the water? Have you gone deep into the water? No idea? Okay. What happens the deeper you go under the water? Do you feel anything? Like, so when I go under the water, Anushka, what have you felt?
It's a really heavy pressure. Like if you dive in.
Yeah, the deeper you go under the water, the pressure increases. And where do you feel it? Like for me, I feel it in my ears. Okay, the water goes into my ear and I get a headache. Okay, because as you go deeper, the water pressure increases and water tries to enter in from wherever it can enter in. Okay, so your ears are open. Your nose, if it's open, it might go into your nose. Some people, when they do deep sea diving, they close their nose or they wear a, that deep sea diving, what do you call that? You know,
Mask.
yeah, like a mask, which does not allow the sea water to go into their nose and eyes and mouth. Okay, they put that covering around there.
And those swimming goggles.
Yeah, the swimming goggles, okay, but a big one they'll put, which covers their mouth and nose also, or at least their nose. Mouth they can close, but nose you can't close, right? So there's a high chance that water will enter into your nose. Yeah, so what we understand is the deeper you go under the water, the pressure increases. You can see that from an experiment like this. Okay, see there's a big jar over here, and if there are two holes made, okay, the hole at the lower surface, lower part of the jar, the water will come out with more force or with more pressure. The word is pressure, yeah. Okay, so deeper you go, the more the pressure. Um, in a tall building, okay, if a building has 10 floors, the person who's living at the ground floor, he'll get the most water pressure. The person staying on the top floor, he'll have the least water pressure, right? Because he's very close to the tank. The distance between him and the tank, or the depth between him and the tank, is very less compared to the person at the ground floor. So when I was going to change a shower, okay, I was going to put a new shower head, and I wanted to choose a big shower, okay, because it's better that way. So in the shop, the shopkeeper asked me, how many floors is your building? Okay, because if it's a big shower head, a lot of water has to pass through it, which means it needs high pressure, which means you need to have a really tall building so that you will have high pressure. So then he said, your building is only 3 floors, so you won't have enough pressure. Okay, but if my building was a 10-floor building, then I would have had more pressure in my shower. You understand? More the depth. So the first factor affecting pressure is depth or height. Okay, we use H for height, which also could be depth. So the higher or the deeper you go under the water, the more the pressure. Okay, that's the first factor. Factors affecting pressure in fluids. Okay, is there any other factor which affects pressure? You can just speak whether you're right or wrong. It's okay. I want you all to think. Any other factors affecting pressure inside a fluid?
The speed at which it's running.
that will maybe that will move you probably, but it does not exert any pressure on you.
Okay.
Okay, let me ask you: if you're in seawater or in fresh water, where do you think there will be more pressure?
Seawater,
Okay, why in seawater?
currents.
No, again, we're not talking about the movement of water. We're just talking about seawater. Suppose I take seawater and put in a swimming pool. Okay, so seawater and normal water.
Dense,
The density,
heavier.
correct. It's the density. Okay, seawater is more dense because of the salt content. Okay, so more the density, more the pressure. You can just imagine, no, there's more heavier water above you. The more dense the water, the more heavier it is. So because of the weight of the water, there's more pressure on you. Okay, so pressure is also directly proportional to density. Now, density is represented as with this symbol here. Do you know what this is? It looks like a P, but it's not in English. It's called rho, R-H-O. Okay, and rho stands for density. H stands for height or depth. Okay, so we have seen two factors affecting pressure. One is height or depth, and one is the pressure, the density. The third factor affecting pressure is acceleration due to gravity. G stands for acceleration due to gravity. Okay, see, look, more the acceleration due to gravity, more force the water will exert on you. Like imagine you're underwater, you're 10 meters underwater. That is, if there's more gravity, then there's more weight. The weight of the water is more. And so that will exert more pressure on you. Okay. So these are the three factors affecting pressure inside a fluid. Okay. Now, if you put all three of them together, we can say that pressure is directly proportional to H, rho, and G, all three. Correct? Okay, just write down these three factors affecting pressure. Write down quickly. Okay. Now, from this relationship or from the factors affecting pressure, they have derived the formula for pressure under a liquid or inside a liquid, which is P is equal to H rho G. Okay, we're converting this relationship into this formula H rho G. Okay. Write down the formula. Okay, done. Now, from this formula, we can come up with certain laws of liquid pressure. That is how pressure behaves inside a liquid. Okay, the first point we can talk about height or depth. So what is that? The deeper you go inside a fluid, the pressure increases, right? Okay, that's the first point. Okay, the deeper or more the depth, more the pressure. Okay, now what if you're at a certain level, say you're 10 meters under the water, okay, and you swim horizontally. So you go to another point which is also 10 meters under the water. Will you feel the same pressure or will the pressure change? At the same depth, you have the same pressure throughout, right? Because you're 10 meters underwater. So the second point is what? In a stationary liquid, pressure is same at all points on a horizontal plane. Okay. Same pressure at equal depths. The third point is pressure is same in all directions about a point. So if you take an object and put underwater, the pressure exerted on top of that object or on the side of that object or even under the object will be exactly the same. It's not like because there's more water on top, there's more pressure down top and less water underneath, so less pressure down, nothing like that. At a certain point underwater, there is equal pressure exerted on their body from all sides, from all around it. Is that clear? Okay, rejoin the meeting. Right. Yeah, turning cameras on. Hiba and Nishta. I have a diagram over here. Okay, we have two containers. One container is filled with water, another container filled with alcohol. Okay, now I've written the densities under it. The density of water is 1 gram per centimeter cube, and the density of alcohol is 0.7 grams per centimeter cube. Okay, which means water is more dense than alcohol. Now I have three different pressures that are felt. Pressure at point A, point B. Then here we have two pressures. Point C is from top to down, and pressure D is from down upwards. And then you have pressure at point E. Okay. Now B, C, D, and E are all the same point at the same level or at the same depth above under the water surface. Now I want you all to speak. Tell me at which point will there be the least amount of pressure? It's an easy one. At which point there will be the least amount of pressure? Nishta, are you there? Hiba has become very silent. Hiba used to talk a lot before. Now Hiba is not talking too much. Huh? Hiba, tell me, at which point there is the least amount of pressure?
At point A.
Okay, at point A, there's the least pressure, and obviously it's because of the least amount of depth, right? The depth means the distance between the surface and that point. Okay, that is depth or height. Okay, now point B, C, D, and E are all at the same level. Now, from those three, if you compare B, C, D, and E, where will there be the least amount of pressure?
E.
Did you say E?
Yes, sir.
Okay, why E?
Because the alcohol has the least density.
Okay, so density. We're talking about the second factor now, that is density, right? Since E has at point E, there's the least density, there's the least pressure. Now look at point C and D, or this point where there are two pressures, C and D. Will the pressure exerted by C or by D be more?
C.
A reason?
Because it's closer to being perpendicular.
No, it's the same point, okay? The
But it's
point,
exerted, one is exerted from above and one is exerted from below, right?
correct. Okay, so will both be same or both will be different?
Different.
Different? What do you all say, Adya, Hiba? Do you think it'll be same or different? Let's read this third point here. Third point says pressure is same in all directions about a point inside the liquid. So according to that statement, what does it mean?
That's the same.
It's the same. Okay, so you might think, okay, above this point there is more water, below the point there's less water, but it's not based on that. It's just based on the depth. So at a point, all around the point there'll be the same amount of pressure. Okay.
Okay.
So yeah,
Yes,
so
sir.
that is the third point.
Sir, could you send a photo of this, please? The slide.
Just take a screenshot.
Okay.
I send a photo. Okay, or I have to take a photo and send. Yeah, or you can I'll give you time to draw it. I know you all don't want to draw. Yeah, just take a photo. But then you have to study that. All right. Now, one more thing. Suppose I take a pipe. Okay. And I fill this, suppose it's empty. Okay. If I fill water till a certain level in this pipe, okay. Suppose I pour water till a certain level over here. What's going to happen to this water on the other side? It's going to flow and it's going to reach the same level even on the other side. Do you think this is right? I'm pouring water into one side of the pipe. Will the water flow through the whole pipe and reach the same level on the other side also? Like, I'm not pouring water from the right side. Okay, I'm only pouring water from the left side.
It's unsure.
Yeah, the water, see the last point, a liquid seeks its own level. That means what, it tries to equalize itself on both the sides. Even if you don't pour water on the right side, you just pour on the left side, the water will flow through the pipe and reach the exact same height on the other side also. Okay, this is
So
very.
is it
Hmm?
so sir, is it correct or is it unsure?
It is correct. It will always form the same height on both the sides. Okay. Now, this is very important because they use this to, suppose you're building a wall. Okay. Just imagine there's a wall. The ground is not very steady. Some places is high, some places is low. So when they're making the wall, they can't make the wall the same way the ground is up and down. The wall has to be horizontal to the surface of the earth. Whether the ground that you're on is up or down, the wall has to be straight. Okay, how do you draw a straight line? How do they make the wall straight? See, I'll draw a wall over here. Is this how a wall is supposed to be? Look at this. This is how a wall is supposed to look. Climbing upwards. No, the wall is not supposed to be like this. The wall has to be perpendicular to the earth, like this. You see? So to make the wall horizontal, did I say perpendicular? Sorry. If the wall has to be horizontal or parallel to the earth's surface, they use a tube with water in it to make it straight like this. Okay. They'll mark 2 points at both the ends where they want the height of the wall to be. Okay. They'll use a pipe. They'll put water at that level, and the water at the same level will tell you exactly how the wall is supposed to be made. Okay. Without the help of this tube, the wall is going to be sloping down or sloping upwards. Even if you're building a house, you're putting bricks in a house, the bricks have to be horizontal. It cannot be slopey. So they use this pipe with water inside to get it parallel to the earth's surface. Okay. So these are the laws of liquid and how they act. Okay, what is the first one? The deeper you go inside a liquid, the more the pressure. Second point is what? On a horizontal plane, the pressure is equal at every point. The third one is in all different directions at a certain point, the pressure is same. Fourth point is pressure at same depth is different in different liquids, right? More the density of the liquid, more the pressure. And the last point is a liquid always seeks its own level, which means, yeah, you understood this diagram, right? The level of water will be same on both ends of the pipe. There's a diagram in the 8th standard book, okay? It's a very weird looking pipe or a container. Okay. Say this is a glass container. Okay. And if the water level is at a certain level on one of the containers, say this is A, B, C, D, and E. If the water level is at this certain point at the A, it will be at the same level in all the containers. Does it make sense, everyone? The water level will be same throughout. You don't have to pour separately in each one. You pour it only in A. The water will enter in and it will reach the same level in all those containers. Yeah. Okay, some consequences of liquid pressure. Again, these are easy things. We'll just go through them. The first one is, okay, let me ask you. We've already spoken about this. Where is there more pressure at the same level? Inside the sea or inside the river? Say you're at 10 meters under the sea, 10 meters under the river. You see that there's more pressure in the sea. What's the reason?
Density.
Density. Okay. So that's one. The second thing, a dam. When they build the walls of a dam, why is the lower portion of the dam built wider than the upper portion of the dam? Have you ever seen a dam? The shape of this dam? You can't see it exactly, but you can see that slope. The lower portion of the dam is very wide. Yeah, why is that?
So it's the pressure is exerted in all directions.
All directions inside a point. Like suppose you're at a certain point, say you're at this point A. At this point A, pressure is
No, I got
exerted
that.
on both sides. Yeah. But why is the lower portion of the dam wider? More thicker wall at the lower part of the dam. Hiba, come on. Nisha, tell.
So since it's the liquid at a depth exerts more pressure, the dam also has to be wider so as
Yeah,
to
to
prevent it
withstand
from
that pressure.
breaking.
Correct.
Yeah.
What if the dam was made like this? This blue is the dam. Okay. So then
It will
the
not break.
yeah, the lower portion of the dam, the walls are not thick enough to withstand that high pressure. Because the deeper you go inside a liquid, the pressure increases. Right. So the lower part of the dam should be much wider to withstand that high pressure. Upper portion does not need to be that wide because the pressure is less over there. Okay. So accordingly, they make the dam narrower on the top and wider at the bottom. Okay. See, what if the whole dam is like this? Then it's going to break over here. Right. What if the whole dam is wide? What if the whole dam is so wide like this? Then will it break? If the dam is so wide like this, it's a waste of material on top. You don't need all this, right? It's just wasting material. So they make it wide at the bottom, narrow at the top. Okay, making it so wide is going to be strong itself. It's not going to be weaker or anything, but you're just wasting material. Okay.
So it's more of an economic decision.
Yes.
Okay.
Just like how you make buildings also. Have you seen the tallest building in the world, Burj Khalifa? How the structure is? You seen it? It's wide at the bottom, and as it goes up, it gets narrower. Okay, so why is it wide wide at the bottom is? Okay. Okay, that's a different reason. That is to decrease pressure, right? The wider you make it, the lesser the pressure. See, there are two formulas for pressure, okay? We need to know when to use which one. One is P is equal to F upon A, and one is P is equal to H rho G. So the first formula is we can consider for like Burj Khalifa, a building that is so heavy, it has so much force, it's exerting a lot of force on the earth. So to reduce the pressure exerted on the earth, we increase the area. Okay. So this first formula is for any object that is placed on a surface. Okay. The pressure it exerts on the surface. That is the first formula. The second formula is when there is an object inside a liquid or inside a fluid, any fluid, liquid or gas. So that's the second formula. So here when we're talking about the water, the dam has to hold the weight of the water, we look at the second formula. Because the deeper you go under the water, the more water pressure increases. Right? And so to withstand the pressure, the wall of the dam has to be wide at the bottom. Okay. Then another example, water supply tank is placed high. I spoke about that. A tall building having the water tank on top of the building, there will be a lot of pressure at the ground floor. Okay. So not only that, Pune city has a tank or many tanks. These tanks have to be placed at high positions on mountains or on a tall tower. Because the higher it is placed, there is more pressure that is felt in houses when they get the water. Then a diver's suit. Person who dives in the sea, he needs to wear a suit which can withstand high pressure. Because as he goes deeper into the ocean, the pressure of the sea increases and it's dangerous for him. Okay. See, his blood also has a certain pressure, right? Your BP is there, blood pressure. So when you go under the water, the external outside pressure, the pressure exerted by the water becomes more than your blood pressure. And that could be dangerous for you. Okay, the amount of pressure exerted on you could even kill you, especially if the water enters into your nose or ears, then you can't withstand that. So to withstand this high pressure, divers, they have a special protective suit that is made of glass or reinforced plastic or cast aluminum. Okay, aluminum is metal, so it's very strong. So that will prevent you from getting crushed under the water. Okay. So the pressure inside the suit is maintained at 1 atmosphere. 1 atmosphere is the pressure outside water, like in the land, in the air. So that pressure is maintained inside the suit. All right, then size of a gas bubble inside water. Have you seen bubbles coming out of water when you're boiling water? The bubble is very small at the bottom. And as the bubble comes up, what happens to the size of the bubble? It increases. Okay, because there's lesser pressure on the top part of the water. Lower part of the water has high pressure, the bubble is small. The bubble grows bigger as it comes up. Or if you have a fish tank, you can observe that. Some fish, they release these air bubbles. Okay, you can look at those bubbles, and as they come up, they grow bigger. Okay. Now pressure exerted in a liquid, not pressure exerted by a liquid, but if you exert pressure onto a liquid. Okay, now look at this. Okay, let me draw it over here for you. Okay. Say you have a container like this. Okay. And it is filled with water. Now say you have two openings, one opening on top, one opening at the bottom. Okay. At A you have an opening, at B you have an opening. And water is overflowing through these two openings. Which one, in which one or through which one will the water go at a more distance? Through which one will water spurt out at a much more distance, A or B?
B1.
Okay, at B, the water will go at a more distance. Why? Because it's lower, right? So there is more pressure at the bottom. At A, the water will just go and fall somewhere here like this, right? Because lesser pressure as you go up. But now we're changing it. We're going to apply pressure. Okay. So I'm putting a piston on top. A piston is something that is airtight, and now we are applying pressure onto the liquid. Okay, now when pressure is applied downwards, what do you think is going to happen? Will it be the same case? At B, the level will be farther than at A? No. Now, since pressure is applied in a liquid, at both the points A and B, there will be equal pressure felt. You understand? When pressure is applied in a liquid, that pressure is equally distributed throughout the whole liquid, and there is equal pressure felt inside that liquid. Okay, see here, there's another diagram similar to this. See, they're applying force downwards, and there are these pipes pointing upwards. And see, at all the levels, the water comes out at equal jet. The jet is at the same height and all. Okay, so this happens because pressure is applied inside onto the fluid. Pressure is applied onto the fluid. So this is given by Pascal's law. Pascal's law states that the pressure exerted anywhere in a confined liquid is transmitted how? Equally and undiminished in all directions throughout the liquid. Okay, when pressure is applied in a liquid, what happens? When pressure is applied in a liquid, that pressure is transmitted equally and undiminished in all directions throughout the liquid. Okay. Nishta, I don't know if you were there. Did you hear what I just said? Okay, so that is Pascal's law. It's a very important law. Pascal's law states that when pressure is exerted anywhere in a confined liquid, that pressure is transmitted how? Equally and undiminished in all directions throughout the liquid.
Yeah,
Now
so what is
undiminished means it does not decrease, it does not reduce. Okay.
okay? It
However,
stays the same.
yeah, however far or however long a pipe is, you apply pressure at one end of the pipe, that same pressure will be felt on the other end of the pipe.
And only in a contained space.
It has to be closed. Yeah, it has to be airtight. The water should not leak. Yeah, it has to be closed.
Okay.
So, using this principle, they have made some machines called hydraulic machines. They're very important nowadays, and they are used to lift extremely heavy weights. Okay, so we'll see how that works. Okay, so this diagram over here. So you can see there are two containers and there are pistons on both the ends. Pistons are something airtight that does not allow the water to come out, and you're able to apply pressure on both the ends. Okay. So now, according to Pascal's law, what does it state? The pressure exerted on one end will be equal to the pressure exerted on the other end. Okay, pressure is the same. Now we know the formula for pressure. Pressure is equal to force upon area. Now when we talk about force, force also means weight. Okay, so say on the left side, the piston has a lesser area, and on the right side, the piston is bigger. Okay, so the area is more on the right side. Okay. According to Pascal's law, P1 pressure on the left side is equal to pressure on the right side. Now, what's the formula for pressure? force upon area. So we can say F1 upon A1 will be equal to F2 upon A2. Okay. Now let's put some values. Let's say that the area on the left side is much lesser, say it is 10 meters square, and the area on the right side is, say it is 30 meters square. Okay. So if I apply a weight on the left side, say I'm applying a force of say I'm applying a force of 20 Newton. Okay. Say I'm applying a force of 20 Newton. Okay. See, on the right side, I'll put a heavier, okay, right side, what force will be felt? So we have F1, we have A1, we have A2. We need to find F2. F2 is a force which will be felt on the right side. So we put these values in the formula. That is 20 upon 10 is equal to F2, which we don't know, upon 30. So what do we get for F2? We get 20 into 30 upon 10 is equal to F2. So F2 is coming to 20 into 3, which is 60 newtons. So how much force did I apply on the left side? We applied a force or weight of 20 Newton. But on the right side, the force became 60 Newton. You see, this hydraulic machine can be used to increase the force. You're applying a lesser force on the left, but a greater force will be felt on the right side. The pressure is same on both the sides. Okay. So the wider I make the second piston, the more force I'll be able to lift on the right side. Do you understand this working of the hydraulic machines? By increasing the area, surface area on one side, you're able to increase the force felt on that side. These machines are used to lift heavy objects like a car. If you take your car to the washing center, they lift your car up and they'll wash underneath it. Okay. Now, what's the weight of the car? Car is like 1,500 kgs. Okay. So now to lift a car of 1,500 kgs, they don't need to have a motor so strong that will lift 1,500 kgs. No, they just need a motor that can lift maybe 100 kgs. And they make this hydraulic machine in such a way that a 100 kg force can lift a 1,500 kg car. How do they do that? Let's draw a diagram. Okay, so same way on the left side, you'll put a small piston. On the right side, you'll put a very big piston. Okay, so on the left side, we have a piston which has an area of, say, 1 meter square. Okay, on the right side, we have a very wide piston which has an area of, say, 15 meters square. Okay, now on the left side, if I apply 100 kg force, what is the force that will be? What's the force that will be felt on the right side? So we use the same formula. We say that according to Pascal's law, P1 is equal to P2. So F1 upon A1 will be equal to F2 upon A2. Substitute the values over here. We're taking force as kgf. We're not converting it to Newton. We don't need to, because you have force on both the sides. When you have force on both the sides, you don't need to make to the standard unit. You can take kgf itself on both the sides. Okay. So 100 kgf force with an area of 1 meter square is equal to how much upon 15 meters square? Okay, so we get the answer F2 is equal to 1,500 kgf. Okay, so what is the use of this hydraulic machine? Just by applying a force of 100 kgf, we're able to lift a car which weighs 1,500 kgf. Did you understand how a hydraulic machine can be used? Now, we see these hydraulic machines everywhere, even brakes of a bike or a car. Okay, there are pistons. Okay, there's a piston near the brake, and there's a piston near the lever where I have to apply the brake, and there's a piston near the brake which stops the bike or car. Okay, so they'll put a tiny piston in the handle and a bigger piston near the brake so that the force gets multiplied. Okay, wherever there's a bigger piston, there more force will be felt. Wherever there's a smaller piston, there less force will be felt or needs to be applied. Okay, is everyone clear of how a hydraulic machine works? In this case, what is P1? Tell me the value for P1. 100 divided by 1. So that is 100 kgf meter square. Okay. I'm not putting the unit. Now, what is P2? P2 also has to be 100. Are we getting 100? If you put 1500 in place of F2, 1500 divided by 15 is what? 1500 divided by 15 is 100. Right. So we can experimentally see that with calculations that the pressure on both the sides are same. Okay. So that fraction has to be same on both the sides. F1 upon A1 should be equal to F2 upon A2. If you increase A2, F2 will increase. If you decrease A2, F2 will also decrease. Is that clear?
Yes, sir.
Now, how can they use this machine? So they use this machine in something called a hydraulic press. Hydraulic press can be used to, like they take cotton. Okay, cotton has a lot of airspace in it. Now, when they are selling cotton, they don't sell it like that, like, all fluffy and puffed up like that. They have to smash it and make it into a very confined space, and then they sell it. So that way, they're saving space. So they take this cotton and they put it in this hydraulic press, and it compresses the cotton into a very small area. And then they pack it like that while it is compressed, and they sell it. Once the customer receives that cotton, he will just open the package and that cotton will just expand, and then they can use it. Also, when you buy a mattress or buy a pillow, sometimes they will crush it like that and give. Okay. Now that they do it differently, they just vacuum pump it. They remove the air out of the cotton, so it gets crushed. Okay. It gets smashed. But they can also use this hydraulic pump to compress it before they do that process. Okay. So hydraulic press is one machine where this is used. The hydraulic pump is used. Then hydraulic jack. Hydraulic jack is what I spoke about to lift a car, right? Where the force is applied has a very less area, smaller piston. But the part where the car is being lifted, there the area is much wider. So it lifts the car wider. Okay, then this is the brake which I spoke about. Okay, a car brake. You see the foot pedal where the brake is applied by the driver. So there's a tiny piston. And then there's a bigger piston where the actual brakes are in the wheels. Okay. So the smaller piston, which is near the foot pedal, is called the master cylinder. Remember these words in case later on when you're driving a car and you need to know these things. Okay. The cylinder near the leg is called the master cylinder. And the other piston here is called the wheel cylinder because it's inside the wheel. Okay. So when the driver, he presses the foot pedal, he compresses the master cylinder, having a smaller area. And what happens? There's a fluid that goes through a pipe, goes to that wheel. And in the wheel, there's a bigger cylinder. And the same pressure is felt inside that cylinder. Okay. But because that piston has a much wider area, there's a much greater force that is felt on the wheels, which that piston is connected to the brake shoe, which applies the brakes. Okay. So the driver, he has to apply a very less force, but in that wheels, there will be much higher force that is applied onto the wheel. Just imagine this machine was not there. Okay. If a hydraulic machine was not there, and then a person is driving a truck or a train, can the force of a person stop a bus or a train? There's no chance, right? So you need something like this which multiplies the force so that you can stop these huge and big vehicles. You all have ride cycles probably. In cycles, do you have all these things? Do we have this master cylinder and a fluid which runs through and all that? You don't have, because you don't need it. Your hand strength is enough to stop a cycle. No, but if you're riding a heavier vehicle, you need much more force to stop that heavier vehicle. So that time we use this hydraulic brakes. Okay, is this the last page of the chapter or is there more?
So there's the B part,
What's the B part?
atmospheric pressure and its measurement.
Okay, and then after that, like, is there a C part also? Let's check.
No, so then it comes to upthrust influence, but I don't think that's in motion.
How many pages of that B part is there?
So if this is your last page, then there's also the next page, half of that, for A part,
Yeah.
and then yeah, and then for B part it's 1, 2, 3, 4, 5, 6, 7, 7.
Okay. All right. Just let's complete this. So there is something called mechanical advantage. Have you heard of this word mechanical advantage? Mechanical advantage is a ratio. It's a ratio between load and effort. So load upon effort. Okay. Now, load and effort both are forces. Load is a force, effort is a force. Okay. Suppose we talk about this hydraulic machine, or like let's talk about this brake. So the person pressing the foot pedal to stop the car, he's applying what? He's applying the effort. Okay. And at the brake, that's where the load is. Load is like the weight of the car. He's stopping the car. Okay. So we have to understand which of the two forces is load and which one is effort. So say in this case, the load he's up, okay. Say he's applying an effort of 10 kg. Okay. So we're putting the load, sorry. He's applying an effort of 10 kg. So 10 is in the denominator. Okay. And say the car is 1000 kg. Okay. So if I put these two values in this formula, mechanical advantage is load of the car upon the effort that he applies. We're getting a mechanical advantage of 100. Okay. Now, if the mechanical advantage is anywhere greater than 1, the machine acts as a force multiplier. We'll be studying in more detail about what this is in the 10th standard. Here you just have a little glimpse of it, okay? If this value for mechanical advantage is more than 1, that machine is a force multiplier. Okay? So say even if he applied let's say a smaller value. Say he applied an effort of 1 kg and the load, let's say he applied an effort of 10 kg and the load was 15 kg. Means with 10 kg effort, he was able to lift 15 kgs. That is also a force multiplier because he's applying a smaller force and the machine is increasing the force that he applies, right, from 10 to 15. So how much are we getting here? We're getting 1.5. We're getting mechanical advantages 1.5. So this machine is also a force multiplier. Okay. So what's a force multiplier? Any machine which increases the force applied. You're applying a less force. Effort is less, but the load is more, then that's a force multiplier. So every hydraulic machine acts as a force multiplier, right? Because it increases the force. Okay, do you all have any doubts from this part of the chapter? Hydraulic machine, how Pascal's law is applied to a hydraulic machine?
I think some of it is cut actually. I'll have to confirm with ma'am. Some of it's functioning or something like that.
Probably one of the hydraulic machines might be cut because I remember once last year or something it was cut.
Yeah, because it's there, the main part is there, but then I remember someone was discussing about it, so I'll have to talk to them.
Okay. Okay, so quickly a revision of what we saw. In a liquid where no force is applied, no external force is applied on the liquid, then we see that the lower you go, the deeper you go in the liquid, there is more pressure. Okay. But if pressure is applied onto the liquid like this, if pressure is applied onto the liquid, there is an equal pressure felt at every part inside the liquid. That is Pascal's law. Okay. In this container, we see even though there's a tube which is at the lowest point and there's another exit at the highest point, both will experience equal amount of pressure. Okay. And this principle is used in every hydraulic machine. What is the advantage of hydraulic machines? They are force multipliers. Right? You apply a less force, but you get a much higher force as an output. So this machine can be used to increase the force, lift cars, press brakes and stop a heavy vehicle with just a person's leg. Okay. So like this is very useful, this machine. Okay. All right. So the A part of the chapter is over. Next time we can see the B part of the chapter. Okay. And then comment.